Okay, in this video I'm going to talk about the theorem about two circles intersecting on the sides of a triangle. So basically the setting of this theorem is the following. So we have a triangle, then we consider an arbitrary circle passing through two vertices of the triangle. So let's say that something like this. Yeah. So it passes through two vertices and intersects two sides. So now we consider these points of intersections and we consider the circumcircle. So let's say the triangle is ABC, and the so let's put this point as P and Q. Okay, and the circle, this circle we denote by omega 1. So the theorem, so like I'm going to start writing the setting of the theorem. So let circle omega 1 intersect let omega 1 be a circle passing through A and C and intersecting the sides AB and BC at P and Q respectively. So now we consider the circumcircle of the triangle BPQ. So this circle we denote it as omega 2. So let omega 2 be the circumcircle of triangle BPQ. And so now the statement is that if we consider the center of this circle omega 2, so we denote it by O. So let omega 2 be the circumcircle with center O. Or like this circumcircle of triangle BPQ with center O. And now the statement is that then the lines BO and AC are perpendicular. So BO and AC are perpendicular. Yeah, so that's the theorem. And so let's prove this theorem. So I'm going to draw another picture. So we have again this triangle. We have two circles that, like another way to put it is that like two circles. We have two circles that intersect each other at the point, like at the sides of the triangle. So like this, that one of them passes through one vertex and the other circle passes through two other vertices of the triangle. And then we have the center here. We need to prove that this is a right angle. So I'm going to remove this right angle. We don't know that yet. So A, B, C, PQ, O. Okay, so what we are going to do is we denote this angle as alpha, right? Now then we draw this segment PQ, and since so the quadrilateral A PQC is cyclic because it is inscribed in the circle omega 1. So it is inscribed in the circle omega 1. So therefore it's cyclic, therefore the angle PQB is equal to alpha. PQB, like this angle, is equal to alpha. Okay, now PQB, now this angle is so this is an inscribed angle, inscribed in omega 2, inscribed, and it subtends the arc PB of BP. So inscribed in omega 2, therefore the arc BP that it subtends is equal to twice this angle, so is equal to 2 alpha. The arc BP in omega 2, of course. Now, like if we denote now this this point of intersection of the BO and the second point of intersection BO and the circle, denoted by I don't know, let's say S. So then the arc PS is like, so we know that since BS is a, okay, so BS is a diameter, right, in omega 2. Therefore, the arc BPS is equal to 180 degrees. because like it's half of the circle. The full circle is 360, and this is half of the circle, it's 180. So this arc. Now the arc, it follows from this that the arc PS is like BPS minus the arc BP, right? So BPS is 180 degrees minus BP, and BP is 2 alpha. So 180 degrees minus 2 alpha, because that's where we found. So so PS, we found that the arc PS, we calculated that it is equal to 180 degrees minus 2 alpha. Therefore, the inscribed angle that subtends this arc, this angle PBS, angle PBS, it's an inscribed angle that subtends this arc PS, right? It's equal to 1/2 of this, 1/2 of the arc PS is equal to 1/2 of 180 degrees minus 2 alpha, which is 90 degrees minus alpha. -90 degrees minus alpha, and this is almost the conclusion. So like we simply denote this point by H. So in the triangle, so basically we found this angle to be 90 degrees minus alpha, this angle. That's what we just calculated. Therefore, in the triangle ABH, in this large triangle, one angle is equal to alpha and the other is 90 degrees minus alpha. Therefore, the third one is equal to 90 degrees. So therefore, the angle AHB is equal to 180 degrees minus angle A minus angle ABH. ABH is the same as PBS. It's simply the same angle. So this is equal to, let's write this carefully, 180 degrees minus alpha minus 90 degrees minus alpha is equal to 90 degrees. So we found that AHB is equal to 90 degrees. So AHB, this angle, is equal to 90 degrees. That is exactly what we needed to prove. So therefore, AC is perpendicular to BO, and the theorem is proven.